It's really good practice. So you roll a standard number cube once. What are all the following? Which to the following gives you all the sample space for this experiment? Obviously C, right? 1, 2, 3, 4, 5, 6, and I would have much rather if they put it in brackets. Okay. 2, a hat contains 5 red, 8 green, 9 yellow. So always start with your total. So here I have 5, 8, 13, 17, what's that, 22? 22 total. All right, so I know my total is 22. And Rena chooses one ball at random from the hat. Use this information for questions 2 to 5. Okay. Let me just bring 2, 5 up. What's the probability that Rena chooses a green ball? Obviously, it's going to be something over 22. Green's going to be 8 out of 22. And obviously, you can simplify. It's probability she chooses a red ball or a green. So a red or a green, she wins. Okay, so there are 5 reds and 8 greens. So remember, or, we know we have to add. So it's 13 out of 22. It's probability that does not choose a red ball. So, do not choose a red ball means she has to choose a yellow or a green. So that's 17 out of 22, and that's J. And this one I'm going to have to go up and down a little bit. And what's the probability she chooses a yellow ball? Obviously, a yellow ball would be 9 out of 22, and that makes it question B. Standard cube is rolled once. What's the probability of a number less than 3? Numbers less than 3 are 2 and 1. So notice that all these questions, the answers are simplified, okay? Which will probably be the same case on your test. 7, spinner has white, green, violet, indigo, and blue sections. Okay, so there's 1, 2, 3, 4, 5. Which of the following is the complement of the event that the spin lands on violet? But the probability of landing on violet, by the way, is 1 out of 5. The complement of that is not landing on 5. Not landing on 5. That's a complement, not landing on violet. Sorry, so not landing on violet. And the probability of not landing on violet, obviously, is 4 out of 5. So that would be the complement. So let's see if I have this right. So which of the events is the complement? The complement will be landing on green, indigo, and blue sections. 1, 2, 3, 4, 5, and white. I forgot white. So white, green, indigo, blue. There we go. That's the complement. Landing on anything except violet. Okay. Probability a new car, a local dealership has a bad headlight is 0.003. So that's written as a decimal. Very, very tiny chance that a new car has a bad headlight. Which statement best describes the probability of this event? It is likely. Well, unlikely. If you want, you can change that to percent. Okay, so let's move that 2 over. 1, 2, and it's 0.03%. Or even if you wanted to write it, you can write it as a fraction, 3 out of 1,000. So for every 1,000 cars, 3 of them would have a defective headlight. So it's very, very unlikely that you get a car like that. Somebody will, but chances are unlikely. Which event is impossible? A bowl has 10 red marbles and 12 green. You choose a red marble from the bowl? No. The bag has a piece of paper numbered from 1 to 100. You choose a number divisible by 3? No. The spinner has section letter A through H. The spinner lands on the 10th letter of the alphabet, which I have no idea what it is. A, B, C, D, E, F, G, H, I, J. So C obviously is the answer we're looking for because a spinner letter A through H is only 9. So if you go A, B, C, D, E, F, G, H, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be a spinner with 9 sections, right? And obviously you can't land on the 10th letter because the spinner doesn't have a 10th section. Okay. You can tell pretty easy questions. I think the whole topic is relatively simple. An A1 truck, customer can order turquoise, a red turquoise, a green truck. The truck can have leather or cloth seats. The customer can also choose from black, tan, and gray interior. How many possible trucks can a customer choose? Well, we multiply the number of options in each category. So we have 3 colors times the interior, which again is 3, and then, oh, I forgot the leather or cloth seat. So it would be 3 times 2 times 3, and we get 6 times 3. We have 18 different trucks can be made with these choices. Okay. Constructed response, I'll do 14 here, only because, you know what, I'll do it in order, sorry. Okay, she draws a marble from the basket. She records the color, puts the marble back in the basket. So this is independent. The experiment is repeated several times. She records the frequency. What's the experimental probability of choosing a green marble? So in the experiment, what's the probability of getting a green marble? It's 14 out of whatever this was. 16, 30 out of 40. Or 7 out of 20. Simplify. Okay. Don't want to move this. Okay. No. No. This is, yeah, so that's 12. A hockey team has 12 girls, 9 boys. Each week, the coach chooses one player random to play goalie. What's the probability that the coach chooses a girl to be the goalie for the next game? So that would be 12 out of how many total? 12 out of 21. And we can simply write, right? So the P of girl as a goalie would be 12 out of 21 divided by 3. We get 4 out of 7. Probability of choosing a 6 at random from a standard deck of playing cards, 1 out of 13. Right? It's actually the probability of getting 6 from my deck of cards is 4 out of 52 because there's 4 6s, right? 6 of hearts, 6 of diamonds, 6 of clubs, 6 of spades, but we simplify to 1 out of 13. Okay, so let's use this information for question 13 and 14. What's the complement of choosing? What's the complement of the event of choosing a 6? Well, the probability of choosing a 6 is 1 out of 13. Sorry. P of 6 is 1 out of 13, so the complement would be not 6, which would be 2 out of 13. Sorry, 12 out of 13. Okay. And what's the probability of the complement of the event of choosing a 6? What did I just answer? What is the complement of the event of choosing a 6? Okay. What's the probability of the complement of the event of choosing a 6? What's the probability? What is the complement of the event of choosing a 6, which is not choosing a 6? What is this? What is the probability of the complement of the event of choosing a 6? I guess here, if I'm interpreting this correctly, this meant what is the complement of the event of choosing a 6? Of choosing a 6 is the complement would be not choosing a 6, and then that information would be what you would put over here, and the probability the probability of not choosing a 6 of not 6 would be 12 out of 13. You roll a standard number cube 1,000 times. Predict the number of times you would roll a 2 or 5. So the probability of getting a 2 or a 5 on a die is 2 out of 6, or 1/3. So to predict out of 1,000 times how many times you would get a 2 or 5, well, you take the probability and just multiply. In this case, you'll get 333.33, right? 333 point. .33333, and we're just going to write it with T. And obviously, you can't roll a die 333.3 times. We're just going to call it 334. So out of the next 1,000 rolls, 334 of them are expected to land on 2 or 5. Okay, and that's the theoretical probability. Use a spinner to answer 16 and 17. Okay, there are 4 numbers on the spinner. One of these numbers is 2. Okay, the probability that the spinner lands on 2 is 1/4. Well, let's see. Probability on landing on 2 is there's only 1 2, 1 out of 8. And she said it was 1/4, which is obviously incorrect. So there's only 1 chance out of 8, right, to land. So that makes her incorrect. What's the second question? There are 2 colors on the spinner. One of the colors is blue. Okay, I'm assuming the dark side is blue. Therefore, the probability that the spin lands on blue is 1/2. Is that true? Well, assuming the dark one is blue, there is 1, 2, 3, 4. 4 out of a total of 8 is blue. So I'm going to write clear blue here, which is 1/2. And then you can obviously write down that you agree, etc., etc. Second part. So again, you can tell that's very, very easy. What's the probability of selecting a 3 from the bag? Well, it's 3 out of, this would be 3 out of, how many numbers here? 3 out of 12. And if you simplify, it's 1/4. What's the probability of selecting an even number from the bag? There's 1, 2, 3, 4, 5, 6. So there's 6 out of 12, or 1/2. Okay. The jar contains 3 different colors: 6 red, 6 blue, 4 red, 2 green. What's the probability of getting a blue? Well, first of all, let's get the total here. The total is 12 total. Getting a blue is 6 out of 12, or 1/2. Not green would be blue and red, or 10 out of 12, or 5/6. And pure yellow would be 0 out of 12. You toss 24 times, you toss 2 dimes 24 times and record the results. So we did an experiment here, that's what we're saying. Here are the results. What's the probability of tossing 2 tails? Well, how many times total here? 24. So probability of tossing 2 tails with 5 out of 24. Tossing 1 tail and 1 head is 15 out of 24, which you can simplify to 5 out of 8. And what's the theoretical probability of tossing 2 heads? Well, the theoretical, so don't look at this anymore. And in theory, look at 2 coins. So what's the probability of getting 2 heads? Well, in theory, the probability of getting heads and heads, right, and then heads, it's 1/2 for the first coin and 1/2 for the second coin. So the probability of getting 2 heads is 1/4, theoretically. And here we go. Okay, so that's based on you observing the coin as opposed to an experiment, the results of an experiment. 9, near line food service finds a recent flight. Alright, so there were 120 people flying, and in that flight, 25 out of 120 ordered lasagna. Okay. So on the next flight, with 380 passengers, they need to decide how many lasagnas to bring on board. So let's use that particular, so 125 over 20, right? The result of that, and we can multiply that by 380. And you can use the wonders of a calculator to do this. And we're gonna get 62, well, what the heck am I wrong here? 120, what are we gonna do? Basically, this is how many with 380, oh, I multiplied by 300, sorry. 25 over 120 times 380. And we get 79 and whatever, 16 simplify. You can't have 79 and 1/6 of a person, so obviously 80. Alright, so we're gonna need 80 lasagna dinners on our next flight. A blue number cube and a green number cube are rolled. Both numbers cubes have the numbers 1 through 6. What's the probability of rolling a number 3? So we're going to roll a number, greater number than 3 would be 4, 5, 6. Right? 4 or 5 or 6 on the first die. And then and times probability a number less than 4 in the green cube. So we want a 1 or 2 or 3. So on the first die, the probability of getting a 4, 5, or 6, which is a number greater than 3, is a half. And the probability of getting a number less than 4, which is 1, 2, or 3, is also a half, because you have it's 3 out of 6 times 3 out of 6, or a half times a half, which is 1/4. 11, if you're taking the number from this box without looking, what's the probability of drawing a 5? Oh my god. Probably drawing a 5 is how many 5s do I have here? 1, 2, 3, 4, 5, 6. How many do I have in total? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 6 out of 20 or 3 out of 10, which is 30%. Miss Harris 5 blue, 8 red, 3 green, and 7 yellow. She selects a candy. What's the probability she will draw a yellow candy? And there's 7 out of whatever the total is here. What's this? 15 plus 10, 25. Am I adding this wrong? 23 candy. So the Pia yellow would be 7 out of 23. Okay. Number cubes roll 1 through 6. Monica needs to roll an odd number to win. Simone needs an even number. How likely is Simone's chance of winning compared to Monica's chance of winning? So obviously they're equal, right? Because one wants to get an odd and one wants to get an even, so they both have half a chance to win. So 50-50. So the question is answer letter B. 14. Which event's most likely to occur? Rolling a number cube, rolled label 1 to 6, and landing on 2 or 4. Well, the chance of landing on 2 or 4 is what? 2 out of 6? So 1/3, right? Randomly selecting a red marble from a jar containing 10 red marbles and 11 blue marbles. So the chance of you getting a red marble is 10 out of 21. Almost 50-50. Randomly selecting a prime number from a hat containing the numbers 1 through 20. So how many prime numbers do you have? Yeah, 20. 3, 5, 3, 5, 7, 11, 13, 17, 19. There's a 7 out of 20 chance. And spinning a spinner with 6 equal sections, label 1 through 6, and landing on 1, 2, 3, or 4. 1, 2, 3, or 4. You have a 4 out of 6 chance. Notice that, well, you know it's either going to be this one, 10 over 21, or 4 over 6. Well, 4 over 6 is 66 points. What do you call it? 66.6%, and 10 out of 21 is 47%. So the most likely to occur, letter D. Okay. So I'll change it to a format, all percents, all fractions, or all decimals, and then compare. 15, stack of 100 cards mixed is number from 1 to 100. It's probably selecting a card that's multiple of 5. Okay. No. Multiple of 5, we have 20 multiple of 5s. Okay, so it would be 20 out of 100, or 1/4. Oh, that's not 1/5, I'm sorry. 1/5, right? George will toss 3 coins at the same time. What's the probability will result in all tails? Well, the probability of getting tails in all 3 coins is a half, times a half, times a half, and 1/8. The numbers 2, 6, 4, blah, blah, written on a piece of paper, placed in a bag. A piece of paper is chosen from the bag. How likely is the number on the paper will be an even number? Well, you put these numbers in the bag, and you take one out. What's the probability it's an even number? There's 1, 2, 3, 4 even numbers out of the 6 numbers. So we're going to say likely. Right? That's 66.6 chance. 17, 18, 16 students have cell phones. 5 of the cell phones have touch screens. Okay, so out of 144 students, how many would you expect to have touch screens? So again, we did a little experiments. 16 kids. 5 out of the 16 touch screen. Right, and then we're going to take that and apply it to 144 just to predict how many of those 144 will have a touch screen phone. And you get 5 over 16 times 144, and we get 45. Do we have 45? 45 kids. Theoretical probability of choosing a green marble is 1/3, okay? If there are 18 marbles in the bag, how many marbles would you expect to be green? So again, same thing as we just the previous problem. So we have probability of getting a green is 1/3. We're going to use that probability to predict what happens with 18 marbles. How many of those would you expect to be green? And obviously, that's just 6. Martin will roll number cube 150 times. The number cube is labeled 1 through 6. How many times could Martin expect to roll a number greater than 4? Well, greater than 2. Greater than 2 would be 3, 4, 5, 6. So that's 4 choices, 4 out of 6 chance of that happening. Now, if we roll the cube 150 times, how many times out of 150 would it land on 3, 4, 5, or 6? That's just 2/3 times 150. And we're going to get 100 times. So out of the next 150 throws, 100 times, we're going to expect it to land on 3, 4, 5, 6. Okay? I think this is it for this. Okay, that's it.